When breaking down the word trigonometry, trig means triangle, and metry means measure. So we can use trigonometry to find the measures of triangles, and specifically what we are going to focus on in geometry is the measurements of right triangles. You can also use this for non-right triangles, but we won't really dive into that in geometry. That will be in higher up math. Okay. A trigonometric ratio is a ratio of the lengths of the sides of a right triangle in relation to a given angle. There are three ratios we will be looking at in this lesson and throughout this unit. Those three ratios are sine, cosine, and tangent. You will always take the sine, cosine, and tangent of an angle. Okay? So if we take a look here, the first ratio we are going to talk about is the sine ratio. That is just the side opposite a given angle over a hypotenuse. So you might be asked, hey, find the sine of angle A. Okay? How we often abbreviate sine, it looks like sin, but we still pronounce it sine. It's just its abbreviation. So this is saying right here, find the sine of angle A. When it's asking you that, it's asking you to find the ratio. Okay? And that ratio is just the opposite side over the hypotenuse. So all we have to do is just make a fraction. Well, it's helpful to know, well, what is the opposite side? And what is the hypotenuse side? We don't need our phone books right now.
I'm just putting it in class.
Okay. Jose, stop with like, not to know. It's like, hard at the beginning. We're not going to charge it right now. Jose used to do his joke. So we are going to start with our angle A. So whatever angle you are finding the sine of, you start at that angle. And you label your sides. It's really important to label. Right? And it's really important to label correctly. So start at the angle. Go across. When we go across, we label that as our opposite, abbreviated OPP. Go to your 90. Go across. We label that as our hypotenuse. And then the side that is left over is always our adjacent. I abbreviate it ATJ. The sine ratio is the opposite over the hypotenuse. So what did we say our opposite side is? What little letter? A. What's our hypotenuse? C. So the ratio for sine of angle A is just A over C. We want to then find the sine ratio of angle B. So we have to start at angle B and relabel. So if we start at angle B and go across, that's now our what? Opposite. Go to our 90, go across. That's always going to be what? Hypotenuse. And the side left over is adjacent. I think that's the hardest one to label. Adjacent again means next to, but I just wait to label that at the end. So now, opposite over hypotenuse. What is our opposite over our hypotenuse now? What is it? E over C. And that's the sine ratio. So the opposite side over the hypotenuse. That's all it wants to know. Okay, what's that fraction for sine based off angle A? Well, it's the opposite over the hypotenuse. Then it's flip-flopped up here in paper. The next ratio we are going to talk about is cosine. Okay? Cosine is just the adjacent side over the hypotenuse. So again, we want to find the cosine. We abbreviate it COS. When we see that, it's just cosine. It's not cosine of angle A. So that means I'm going to start at angle A. And I'm going to relabel. Start at angle directly across. We label that as our what? That's it. Go to our 90. Go straight across. We label that as our hypotenuse. And the side left over is the adjacent. Cosine is adjacent over hypotenuse, so that ratio is going to be what? the cosine ratio for angle B. So I start at B. What's staying the same every time? The hypotenuse, right? The hypotenuse is always the side across from the 90. So we can just leave hypotenuse there. Okay? So if I go across from B, that's my what? Opposite. Across from the 90 is still your hypotenuse. That side left over is the adjacent. So now what's the cosine ratio for angle B? A over C, yeah. Adjacent over the hypotenuse. The third ratio we are going to talk about is the tangent ratio. That's just the opposite side over the adjacent side. We abbreviate tangent, T-A-N. It's not tan. When we see that abbreviation, we just say tangent. Okay? That, again, opposite over the adjacent. So we have to label based off that angle. We're finding the tangent of A. So I'm going to start at A. We go across from A. That is our opposite. Across from the 90 is our hypotenuse. That stays there. Side left over is adjacent. Tangent opposite over adjacent. So our tangent ratio for angle A is going to be what? Over B. Opposite over adjacent. And then we now want to find the tangent ratio for angle B. Across from B against our opposite. Across from 90's hypotenuse. Side left over is adjacent. What is now our tangent ratio for angle B? B over A. Questions over that? Okay. If you look at that box at the bottom, there is a helpful saying that we can use to remember these ratios called SOHCAHTOA. Okay? How I like to write SOHCAHTOA, where it comes from and what it means. S stands for sine. The S stands for sine. The ratio for sine is opposite over hypotenuse. So I like to make a little mini fraction and put O over H. So, opposite over hypotenuse. C stands for cosine. The ratio for cosine is the adjacent over the hypotenuse. I make a little fraction next to the C, saying adjacent over hypotenuse. And T stands for tangent. That's the opposite over the adjacent. Every time I do a trig problem, I write that at the top of my paper. Fortunately for geometry, when you take the OST, they wrote the ratios for you on the formula sheet. It literally says sine of A equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. Tangent equals opposite over base. They wrote that for you on your formula sheet. I'll give you this for practice. I'll give you this for quizzes. I will give you this for tests if you have it. The thing is, when you go into like algebra 3 or like pre-calc or when you take the ACT and these right triangle trig questions are on the ACT, they don't give you them on the ACT. Right? So it's important to get in the habit of using SOHCAHTOA, but right now, if you're just having a hard time remembering that, use your reference sheet. Okay? So you're going to see me write SOHCAHTOA, you're going to see me use SOHCAHTOA, but keep in mind it's also on your reference sheet. In your reference sheet, it has it all nice and spelled out for you. It's just good habit to use SOHCAHTOA because you're going to use it later on when you're not given a formula sheet. And it has all those ratios on it. So we take a look at the back. I'm going to write SOHCAHTOA on my paper. SOHCAHTOA. First example, I want to find the sine of angle Z. Again, that's sine of Z. That's what that says. Well, I'm going to circle Z. That's what I'm finding the sine of. Circle Z. Label all your sides based off Z. So I'm going to go directly across from Z. We label that as our what? Opposite. Go to your 90. Go directly across from your 90. That's our what? And what do we label the side left over? I'm finding sine, so I go to S. Sine is opposite over hypotenuse. Well, what's our opposite?
41.
What's our hypotenuse?
35.
21 over 35. You can leave it like that. That's totally fine. You don't have to simplify your fractions. OST doesn't care if you simplify your fractions or not. I don't really care if you simplify your fractions or not. But for good practice, because you probably will have to simplify them eventually, what does 21 over 35 simplify down to? 3 over 5. So if you write 3 over 5, that's correct. If you leave it as 21 over 35, that's also correct. Both ways are correct. Example 2, we want to find the cosine of angle A. So I'm going to start with angle A. That's what I'm finding the cosine of, and label my sides based off that angle. If we go across, that's our what? Opposite. If we go to our 90, go across, that's our, and the side left over. I'm finding the cosine, so I go to C. The ratio for cosine is what over what? Adjacent over hypotenuse. What is our adjacent? 30. What's our hypotenuse? There you go. Totally fine to leave it like that. Good practice though. What is 30 over 34 simplify down to? Both answers, either form are correct. Simplified fraction or non-simplified fraction, I don't care. And the last one, we want to find the tangent of C. So I'm going to circle C. Label my sides based off of C. I'm going to go across. That's my what? Opposite. Go to my 90, go across. That's our. And the side left over. I'm still on adjacent. Real weird there.
So if I'm getting this correct, whatever the way you point it at and whatever it's pointing at is the opposite.
What do you mean?
Like you see how you did the A and then it points down the opposite and then you did, and then it says C and then it's pointing right to the opposite, like this side, right on the other side of it.
Yep, directly across the drops. Yep. So you start at your angle, you just go literally directly across from there. That's your opposite. Directly across from the 90 is your hypotenuse. And then whatever the side you didn't label. So then, tangent. Go to T. T stands for tangent. It's what over what? Opposite over adjacent. Opposite. What do we label as our opposite? 14. What do we label as our adjacent? There you go. Leave it as 14 over 48. Totally fine. But just to practice, what is 14 over 48 simplify down to? 7 over what?
Now we can simplify this question.
Again.
No.
If it was 6, you could. Or an 8. 7. Questions over that? If we take a look at example 4, we're going to find the cosine of A. So let's label our sides. Start with A. That's what I'm finding the cosine of. Go across. That's our what? Opposite. Go to your 90. Go across. Side left over. Adjacent. If we look at SOHCAHTOA or your reference sheets, SOHCAHTOA, cosine is what over what? Well, what's the problem? We're really adjacent. So, do we just give up? Say no answer?
No, you did the
What can we do?
opposite with the
You can do the Pythagorean theorem. Because this is a right triangle, correct? Yeah. So how do you find the missing side over a triangle? Pythagorean theorem. So if you're trying to make a ratio, and you're not given one of the sides, the side that you need to make that ratio, just use the Pythagorean theorem to find it. Okay? The hypotenuse is always our C, and then it doesn't matter, make that my A and that my B. A is 10, so 10 squared plus B that's what we're trying to find, equals c squared, which is 26. And then solve for b. So what is 10 squared? 100. What is 26 squared? 676? What do we have to do to get b by itself? Subtract 100. 676 minus 100? What do we have to do to both sides? And what's the square root of 576? So that's what our adjacent side is. It's 24. Now that we know what that is, what's our ratio? We said cosine's adjacent over hypotenuse. What is the adjacent over the hypotenuse? And again, you could leave it like that. But again, for good practice, what does it simplify down to? Questions over that? Again, when you're trying to make a ratio, if one of your sides is missing, use the Pythagorean theorem to find it. And then you can make your ratio. We take a look at example 5. It says in the right triangle below, sine of b equals 0.6. If the area of the triangle cannot be 6, what's the length of side BC? Well, you're going to have to use a calculator because decimals that you use for OST doesn't allow you to convert decimals to fractions. Okay? Because the reason why we need to convert, we're used to seeing the sine, the cosine, and the tangent as a fraction, right? Fraction form, okay? And we can use that fraction to tell us what the sides are. Because remember, this was the adjacent over the hypotenuse. So that's telling me the adjacent side is 24, the hypotenuse side is 26. Okay, so we can use that fraction to tell us what the lengths of the different sides of the triangles are. So if we can make that into a fraction, we at least know what two sides of that triangle are, and that can help us find the third side. So I'm going to do my calculator. If you have your graphing calculator, you're going to do 0.6, do 0.60 to match what they wrote. If you do math, enter, enter, converts it to a fraction for you. So it gives you 3/5. So really, if we write that in fraction form, the sine of b, oh gosh, I cannot write today. The sine of b is really 3/5. Okay? So, if we look at SOHCAHTOA, if you guys are working ahead, you might need to pause and follow along if you're confused. I'll explain it here in a second. You might need to pump the brakes and watch. Okay. Sine is opposite over the hypotenuse. So let's label our sides based off angle B. Because that's what we took the sine of. So if we go across, that's my opposite. Go to the 90, go across, that's your hypotenuse. Side left over is your adjacent. But we said sine's opposite over hypotenuse, so the side that I label opposite, what's its measure? 3. The side we label hypotenuse, what's its measure? Well, we want to know the length of BC. Similar to the last problem, how can we find that missing side? Pythagorean theorem. Our hypotenuse is always our C, and I'll make this one my A, make that my B. Plug it in. What am I doing? Squared equals 5 squared. What is 3 squared? 9. What is 5 squared? And then what do we do with 9 to get B by itself? So I get B squared equals, what's 25 minus 9? What do I have to do to both sides? And what is B? Square root of 16 is 4. So that is the length of BC. I'm going to draw that in green. You can see a little bit better. But we have to make sure it fits that criteria. criteria that the area of the triangle can't be 6. So, the area of a triangle is 1/2 base times height. What's our base? 4. What's our height? 3. Problem. But, let's go back to this one. Here we had 24 over 6. Right? And that can simplify down to 12 over 13. Well, what do you multiply 12 by to get 24? 2. What do you multiply 13 by to get 26? Isn't this the same fraction? If we do 24 divided by 26 in our calculator, is that the same as 12 divided by 13? Yeah, it's the same, right? The ratio didn't change. It's just 2 different numbers. So, couldn't we dilate this triangle by a scale factor, make it bigger, then it'll keep that ratio the same, but it'll change the area. What do we want to dilate that triangle by? 2, right? So we multiply all of our sides by 2. This new side is now what? 6. This new side is now, and this new side is now 8. So let's see. Let's find the area now with BC being 8. So our base is now doubled to 8. Our height has now doubled to 6. What's 1/2 times 8 times 6? 24. Well, my area is not 6. Let's make sure my sine is still 0.6. So we do sine is opposite, which is now 6, over our hypotenuse, which is now 10. Well, is 6 divided by 10.6? Yeah, we're cool. The sine is still that ratio. It's still 0.6. But my area is not 6. So BC is 8. BC also could have been 12. You could have dilated it by 3. BC could have been 20. You could have dilated it by 5. BC could have been 16. You could have dilated it by 4. There are multiple correct answers. There's one incorrect answer. BC cannot be 4. That was a tough one. Good one to do. Good problem. Okay. You won't see that too often. Okay. I'm not going to make that like a main test question or anything, but good enough. Good to do. Good to count. Okay. Questions over that?